our final presenter is Matthew Lefler from the chemistry department. The title of Matthew's presentation is Making Carbon Nanotubes from Thin Air.
So I hope we can all agree that climate change is bad. And it's caused in large part by excessive emissions of carbon dioxide, or CO2, into the atmosphere by various industrial and a lot of non-industrial processes. My lab is working to reduce atmospheric CO2 by converting it into something else. And we're doing this via electrolysis. Okay, electrolysis. Let's break down what that means. Pun intended, since electrolysis is literally the breakdown, or lysis, in this case of CO2, via electricity, which is just the movement of negatively charged particles called electrons. Now, when we put electrons into a certain liquid salt containing the carbonate ion, which is this thing with 1 carbon and 3 oxygen atoms, we can extract the carbon. And it takes the form of carbon nanotubes, which are just extremely small tubes made out of carbon. Now, these carbon nanotubes have some really cool electrical and physical properties. They are very electrically conductive, and they're lighter but stronger than steel, which, as you can imagine, gives them a whole range of applications from energy storage to material strength, which lends itself to automotive and aerospace engineering, even textiles. You can make a bulletproof suit out of it. It's a really cool, really versatile material. So now that we've removed the carbon, we're left with the 3 oxygen ions that are attached to it. Now, oxygen ions don't really like existing by themselves. So 2 of them will give up their electrons and combine to form a molecule of pure oxygen, the stuff we breathe. This 3rd oxygen ion is then free to absorb carbon dioxide, reforming the carbonate liquid salt, which can then go through this entire process again. So essentially, all we've done is absorbed carbon dioxide and split it into a really cool carbon product and pure oxygen. Now, my research focuses on the liquid salt, the carbonate liquid salt that we're using. We are currently using lithium carbonate, which is the same salt that's used as a medication to treat bipolar disorder. It's also used as a lithium ion source for batteries, such as you'd find in your cell phones, computers, electric vehicles. So it's a very in-demand salt. I'm trying to find a mixture of other carbonates that don't use lithium and instead use sodium, potassium, calcium, barium. These salts are much more readily available, meaning they're much less expensive. And so if I can make the same carbon nanotube product with these salts, then this process of converting what is essentially a waste product with detrimental environmental effects into a really valuable, versatile material would be viable on a worldwide scale. Thank you.